Hi guys, I'm Shushanta Devnath, your chemistry teacher for today. Today we are going to discuss a very important topic that is a part of chemistry and you could say the fundamental of that part, that is the organic chemistry. Whenever you are going to be promoted in the grade 11, that is in the 10 plus 2 level from your secondary level, these particular things you should have to know whenever you are going to start the study of organic chemistry. So first of all, I'd like to say chemistry has four different parts, that is the organic, inorganic, physical, and analytical. So here today we are going to start the general organic chemistry, or the part where we will study this organic chemistry. Okay, so let's see. So today our topic is general organic chemistry. So first of all, if we want to start this one, we need to understand one thing, that the building block of organic chemistry is carbon atom. Okay, the carbon atom. So if you want to understand the organic chemistry, you need to understand carbon first. Okay, so carbon, its atomic number is 6. Okay, so if you want to write the electronic configuration, considering all these rules of writing the electronic configuration, that is the Hund's rule, Pauli's exclusion principle, and the Abba principle. Okay, so according to that, it would be 1s2, 2s2, 2p2. This would be the electronic configuration. But one more thing we need to understand over here, that this is actually carbon's ground state electronic configuration. So whenever we are writing this electronic configuration over here, this is actually we are trying to say the ground state electronic configuration. So whenever the carbon will react, okay, suppose it's going to make some compounds out of it, so that state carbon want to get promoted to the excited state. So what I am trying to say, that carbon in ground state will not be able to react with anything. So first it needs to promote itself to the excited state. So what exactly is going on over here? Suppose in ground state, if we try to write the electronic configuration in this manner, where this is 1s, this is 2s, and this is 2p orbitals. Okay, so this would be the electronic configuration. Okay, so like this we are maintaining. But whenever it will try to react with something, it needs to be a little bit different. It needs to be in the excited state. So what is exactly that? This particular electron from here will get promoted to over here just to get some stability out of it. Okay, so see, so at this moment what's going to happen, let's see. This is the core electron. 1s electrons are the core electrons because this is very close to the nucleus, and nucleus has the maximum effective nuclear charge on these two, that is the 1s orbitals or 1s electrons over here. So these electrons are pretty much inert, that is we cannot take these electrons under consideration or in the reaction part because it's not be used in the reactions. Okay, so what's going to happen to 2s and 2p electrons? One electron has been promoted from 2s to 2p. Okay, and this is the electronic configuration over here. So what is it? It's actually the excited state electronic configuration. Okay, and in this excited state, it's going to react, it's going to produce some compounds out of it, and that's it. Now one more thing to understand over here, see how many unpaired electrons are over here, because whenever carbon will react, they will react with these unpaired electrons. So here the total number of unpaired electrons is 4. Okay, total number of unpaired electrons are 4 over here. So these unpaired electrons is leading it to its valency, because these electrons will take part in the valency, and in that case we are going to say that carbon's valency is 4. This is also the valency of 4. That's why you always say whenever carbon is making any compound, it has 4 hands. How you're saying, if I discuss about the very basic compound of carbon that is containing only one carbon atom, that is methane. Okay, suppose this is our methane, CH4. Okay, now if you try to understand its structure, you could see this, what is going on over here. If I try to draw this picture, these are the bonds. Now you might ask that why I have provided these two bonds like this. So as we are drawing this structure on a two-dimensional page or two-dimensional board over here, these two bonds, which is over here, this one and this one, these two bonds are actually on the surface of this paper or the board. And this particular bond is out of the paper. It's going apart the paper. And this particular one is going behind the page. So this is pretty much three-dimensional representation in two-dimensional surface. And we need to try and draw this picture like this. Okay, we chemists usually draw the pictures like that. All right, so this is the carbon, and as why I have drawn this to you, just to show you that there is 1, 2, 3 and 4 number of bonds of 4 bonds. Okay, so that's why we are saying that carbon has 4 hands. Now if we go to the carbon compounds, how many types of compounds are possible out of carbon, or the organic compounds we are talking about over here? Suppose if we try to categorize them, if we try to categorize organic compounds, the first category or first two different category would be the acyclic and cyclic. What is an acyclic compound? It is a long chain. No cycle is there, no ring formation is there, just normal simple long chain structure. Okay, and cyclic might be the different kinds of cyclic structures, or ring structures are coming under the category of cyclic compounds. So how many acyclic compounds are there? How many types of acyclic compounds are there? So among this we have normal, alkane, alkene and alkynes. So what are these? Alkane, the first one is the alkane, where the carbon is only having the single bond. Whatever the number of carbon atoms are there, all are singly bonded. Okay, now the alkene, alkene having the double bond, and alkyne is the triple bond. So let us write over here, this is for single bond, or sometimes we are also calling it sigma bond, and alkene is the double bond, and alkyne is having triple bond. Okay, so this is up to that. Now in the cyclic compounds, so many different cyclic compounds are there, starting from the cyclic unsaturated compound just like benzene is there, and their derivatives are there. And along with that, if you are trying to find out some single bonded cyclic compound just like the cyclohexane, so many different possibilities are there. But here, as we are going to study the fundamental things, first let us consider this alkane, alkene and alkyne, and we will see some examples. Let's see some examples over here. So alkane in daily life is a very important compound is there, C8H18, that is called octane. It's a normal long chain alkane, but you know where we are using this? This is the main component of petrol, and we are considering it as an energy source every single day that is making our life easier, much easier. Okay, so this is an octane. Now if we are considering an alkene in our daily life, the main component would be this one, which is named as ethylene. Ethylene, what is this? I think you all know about the polyethylenes. That is the carry bags we are using every single day whenever we are moving to the shops or anywhere. This is the ethylene. So the polymer of this ethylene is called polyethylene. Now if we are considering this, an example or real life example of alkyne, this is called acetylene. That gas is combined with oxygen and used as a flame, oxyacetylene flame. So I think you people has already came to know that how these compounds or these organic compounds are useful in our daily life, and might be that is also very promising that our whole body, whole universe, and this whole earth is made up of different kind of compounds, and wherever you want to see, you will see the chemicals in there. Even the water itself is a chemical, carbon dioxide is a chemical, and this petrol, this ethylene, this acetylene, and like this, thousands, millions of compounds are there which we are using every single day in different aspect of our life. So this is also very important, and thank you for watching this video.